So you need to know how recreational drugs affect the central nervous system. This typically comes up as a shorter answer question, however I have seen it as an 8 marker. So recreational drugs are drugs taken with no medical basis and are taken for enjoyment. They also bring function, for example, mood, perception and consciousness. For examples of recreational drugs are cocaine or heroin. The brain contains a reward pathway which causes us to experience pleasant or rewarding feelings. This encourages to repeat a behavior that activates the pathway. However, recreational drugs hijack this reward system and produces the pleasurable feeling without any adaptive functioning. An example of a reward pathway is exercising and then feeling good because you've exercised. You get the reward feeling for doing something good. The mode of action describes how a drug or any other substance produces an effect in the body. Drugs change the way neurotransmitters work. Most drugs have an impact on the dopamine system. Specific examples of drugs and how they affect the central nervous system. Opioids, for example heroin or morphine, they reduce GABA activity. This leads to an overactivity of dopamine neurotransmitter in the reward pathway of the brain. Cocaine, this increases the activity of dopamine pathway by blocking the reuptake of dopamine. Alcohol, this has a depressive effect on the nervous system. It acts to inhibit the neurotransmission by increasing the action of GABA. If you don't know what GABA is an inhibiting neurotransmitter. Nicotine targets aspects of the dopamine pathway, increasing the amount and transmission of dopamine by blocking enzymes that break it down. This mimics acetylcholine and binds to the nicotine receptors. Cannabis binds to cannabis receptors in many regions of the brains. Dopamine neurons do not have these receptors, so instead cannabis blocks GABAergic neurons. Amphetamines, they work by increasing dopamine and noradrenaline in the synapse, by changing the reuptake process so it works in reverse. Amphetamines force the release of these neurotransmitters and can block reuptake. In high doses, it can inhibit their breakdown by enzymes. Individual differences. How drugs and their effects change to person despite sharing a common biological mechanism. Expectations. A mood or what they expect from a drug can affect how the dopamine system responds. If someone believes that a drug will make them feel good, the brain's reward system may make the experience feel stronger. Younger people have a developing dopamine system, making them more sensitive to drug rewards, whereas older people often have fewer dopamine receptors, so they may experience weaker drug effects or need a smaller dose. Fat-soluble drugs are stored in fat cells, which may cause them to have a longer-lasting effect in people with more body fat. Fat cells don't have as much dopamine receptors. People with more muscle may metabolize drugs faster. Liver and kidney function. If a person's liver or kidney doesn't work well, then drugs may stay in the body for longer, overstimulating the dopamine system and increasing the effect. Conditions like ADHD or depression that involve changes in dopamine. People with these conditions may experience drugs differently, such as stronger or weaker effects, depending on their dopamine system and how it works. Relevance. Regular drug use can reduce the number of dopamine receptors, meaning people need more of the drug to have the same effect. Withdrawal. After stopping the drug, the brain may become sensitive to dopamine, making people crave the drug more or feel the stronger effect if they use it again. Strengths. The supporting research is lab-based, and therefore they have controlled procedures which are standardized. They are credible in saying that the reward pathway relates to dopamine, which is a neurotransmitter giving pleasure, and recreational drugs work on the reward pathway to increase pleasure. The credibility comes from observation of those who take recreational drugs. They tend to experience extreme highs, addiction, and withdrawal. There's a lot of supporting evidence. Olds and Minor, 1954, found that pleasure center in the brain in rats. Stryker et al. 2012 looked at the effect on cannabis and found an effect in the hippocampus of mice. However, this theory is reductionist. There's complexity in how the transmission works in the brain that is hard to capture. Current tools cannot measure transmission. Cannabis limits hippocampus activity, but also leads to more dopamine activity, and there's more than one reward pathway. Having one explanation for the mode of action of recreational drugs seems rather simplistic. Conducting human research is difficult. Scanning and finding out about receptor activity is not straightforward. Scanning needs to be more sophisticated, and the focus is currently on the transmitters that are easily studied, therefore all conclusions are about transmitters. There may be others which we cannot study in this moment in time. The use of animal studies as supporting research is hard to extrapolate to humans. It's difficult to study transmission. Current tools cannot measure transmission. For example, cannabis research focuses on the side effect of GABA and glutamate because these are easy to study. Having one explanation for the mode of action of recreational drug is simplistic.